Leo, let's start now.
Okay.
And before to start random variable, I'm telling you the basic formula or basic definition of probability. Okay. So,
Okay.
probability is just chance to get a favorable outcomes on whatever we want. Like if we toss a coin, then if we want to get hat, so the probability to get hat means chance to get that hat, or we can say in easy words,
Okay.
possibility to happen an event is said to be probability, and its formula is,
Okay.
are you getting me?
Yes, ma'am. Yeah.
Okay. If you have any doubt, then you can ask me. I'll repeat. Okay. So
Okay.
probability means chance, or we can say possibility to happen an event. So its formula is
Okay.
probability is equal to number of favorable outcomes upon total number of outcomes. So now we need to understand what are outcomes, right? So let us know about outcomes.
Okay.
So let us take an experiment to understand these things well. You got this formula? It's so easy. If you have any doubt, then I'll explain you, okay? After understanding outcomes, okay?
Okay. Okay.
So let us take an experiment when we toss a coin. So example is, if a coin is tossed once, then outcomes we can get head or can get tail, because when we toss once a coin, either we can get head or tail. So these are outcomes. Okay. So now if
Okay.
we want to find probability to get head or to get tail by using this formula, let us know. Probability to get head is equal to, let's see, number of a favorable number of outcomes, because we want to get head. So favorable outcome we have only here one. Okay, write
Okay.
down one.
Yeah.
In total we have two. So probability to get head is equal to 1 by 2. Similarly, we can find for tail also, because for tail we have also only one favorable outcome. Are you getting me?
Yeah.
Yes.
Yeah.
So this is about when we toss a coin only once. but they'll give you like lots of trial, like in binomial distribution and further distributions, they'll give you more trials. So let us know this
Okay.
one. Now we will do for 2 trials, then for 3 trials. Then you will understand well how can we take outcomes, can form this
Okay.
probability distribution. Okay,
Okay.
you got this till now?
Yes, ma'am.
Okay. Next experiment we are taking if a coin tossed twice or 2 coins tossed together at once, then you will have same outcomes. How? Let us know. Either
Okay.
you toss a coin twice or 2 coins tossed together at once. Let us understand.
Okay.
So outcomes, we can get tail on both coins, or we can say we can get tail in both toss. Are you getting me? If we are
Yes.
using single coin, then we can say we can get tail in both toss. Or if we are using 2 coins, then we can say we can get tail on both coins. Okay. Or
Yeah. Okay.
next, we can get tail on first, head on second, head on first, tail on second, and can get head on both. These are all
Okay.
possible outcomes. You got?
Okay. Yeah.
Now, let us know about sample space. Sample space is equal to set of all outcomes. It is denoted by S, and it is set of all outcomes. So let us put here all outcomes. This is sample space. You got?
Okay. Yeah.
Yeah. So now we'll consider random variable. We can consider in previous also, but there not much to do. Okay, because we have only 2 outcomes and can have only like outcome of had only 1 and for tail. Now you will understand well by using this example, random variable.
Okay.
If we want to find probability to get hats, then we will take this random variable which represent number of hats. If we want to find no, probability to get tail, then we can take accordingly. Okay. And I'm telling you one more thing,
Okay.
just focus to understand. I'll give you this whiteboard as PDF to you. Okay. And we'll also provide you this live lecture recording. So not to worry. Just concentrate to learn.
Okay.
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 So let X be a random variable. Which denotes, if you want to find for hash, so we are taking accordingly which denotes Number of heads. Now we will find probability accordingly and we'll find discrete probability distribution. So,
Okay.
yeah. See, take random variable here and outcomes and can get probability here. Probability for X means for random variable.
Okay. Okay. Understood.
So for no head means only tail. We have outcome. This is when we got tail on both coins. For one head,
Yeah.
we have outcomes tail head and head tail. And
Yeah.
maximum we have two heads and we have only one. Now let us find probability accordingly.
Okay.
So a number of favorable outcomes, we have only one. And total number of outcomes, we have 4. See, in this experiment, we have total outcomes 4. Okay. So for
Cool.
no head, we have only one outcome for no head. Are you getting me?
Yeah.
For
Yeah.
for one head, we have 2 outcomes for one head.
Yeah.
And we can write it as 1/2. And here we have
Okay.
also one outcome for
One.
2 heads. So probability will be 1/4. Now you got it?
Yeah. Understood. Yeah.
By using values of random variable and corresponding probability, we can form probability distribution. How?
Okay.
Like we can write in this way. And I'm telling you one more thing. This is discrete random variable. Why it is? Because we have values. In continuous, we will have class interval. Okay, like this 0 to 1, 1 to 2, 2 to 3, like this. We will have like this. Okay, but we have here only value like 0, 1, 2. So we when we have value, then we say discrete. Okay, we can count them. And when we have interval, then
Okay.
and when we have continuous, like if we have like 0 to 1, 1 to 2, 2 to 3, then we can say continuous. Why? Because its upper limit is equal to lower limit. Okay. If we have like 0 to 1, 2 to 3, 4 to 5, this is not continuous. Why? Because this values of limits are not in continuous. How? Here is 1, here 2. Are you getting me this point? See this point?
Yes.
Okay. So continuous means its upper limit must be equal to lower limit. Its upper limit must be equal to lower limit of the next class interval. Okay. So
Okay.
here
Okay.
we have countable values. So we say this is this random variable is discrete and this probability distribution is discrete probability distribution.
Okay. Okay.
So we have value 0 and its probability is 1/4. And for next, we have 1 and its probability is 1/2. And for 2 heads, we have 1/4. You got this? And which is
Yes.
this? Okay, which is discrete probability distribution. Okay. And this probability distribution we form when we toss 2 coins together at once or one coin is tossed twice. Okay, because they can give you question like this, like a coin tossed twice or thrice, or three coins or two coins tossed together. Okay, that is why I told you in both way. You got it now? Let us take
Yes, ma'am. Yeah.
one more experiment. Okay, then I'll tell you properties of probability. And then we'll do further
Okay.
distributions like binomial and normal you will have in your syllabus. So till now you got everything or want to ask?
I've understood everything so far.
Okay. So let us take one more experiment and then we will know properties of probability,
Okay.
which are most important. If a coin tossed thrice or three coins tossed together at once, then outcomes we can get tail, tail in all trials, or we can say on all coins. We can get two tails and one head in three ways, like this. And can get two hearts in three ways, like this. And maximum can get three hearts. Are you getting me? These are all possible outcomes
Yes.
because, yeah, we can get a no heart
Yeah.
in this condition. Okay, can get two, like one heart in these three ways and two hearts in these three ways, and can get maximum
Yeah.
three hearts. Okay, so
Yeah.
we are taking x as a random variable which denotes number of hearts, because they'll ask you usually for hearts.
Okay.
Okay, rarely will ask for,
Okay.
but usually will ask for hearts. So let and
Okay.
sample space they'll ask you rarely, but we need to know. Okay, so sample space S is equal to, let us take all outcomes. So this is sample space. Now let us consider random variable.
Okay.
Let X be a random variable. Which denotes number of heads. Then we can find probability. See, here, this is not mandatory to write here outcomes, just for understanding, okay?
Okay.
Because we can find px by using x only. This is for understanding. Later, you'll find directly, okay? Not writing here outcomes. So for no had, x is equal to 0 for no had, and we have only one out. See, total we have 8 outcomes here. Total we have here 8 outcomes. So for no had, probability is 1 by 8. Okay, because we have only one favorable outcomes and total we have 8. So its probability for x is equal to 0 or for no had is 1 by 8. And for one had, we have outcomes H, T, 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 H, T, and T, T, H. So we have 3 outcomes, 3 favorable outcomes, and total we have 8. And for two hats, we have H, H, T, H, T, H, and T, H, H. Here we have also 3 outcomes, 3 favorable outcomes, okay. For 2 hats, and for 3 hats, we have only 1 outcome. So its probability will be 1 by 8. You got?
Yes.
Px represent probability for X. Okay.
Okay.
In some material, they can give you like Px is equal to small x. So this is small x represent these values. Okay. So either you can
Okay.
write
Okay.
Px is equal to Px is equal to small x, meaning is same. Okay. So if
Okay.
anywhere you have this, so meaning is same as Px, not to worry. Okay.
Okay.
Because sometime you will see this form,
Yeah.
so can be confused, but meaning is same. Now you got?
Okay. Yes, ma'am. Understood.
Okay. So now let us form probability distribution by using x and px. Then we will do properties of probability.
Okay.
Its probability is 1 by 8. Its probability is 3 by 8, and it is also 3 by 8, and it's 1 by 8. And which is discrete probability distribution. Got it?
Yes.
So to till now, you got each and every step, or want to ask anything?
No, ma'am. I've understood this so far.
Okay.
Yeah.
Now we will do properties of probability.
Okay.
properties of probability. First property is Px is always greater than or equal to 0 and less than equal to 1. Meaning is that probability cannot be less than 0. It cannot be negative in any case. It cannot be more than 1. Okay. And next property is summation Px is equal to 1. Means probability of an experiment, like sum of probability in an experiment, is always 1. So let us verify these properties in our experiments which we have done today. See, let's start with first experiment. When we toss a coin. See, so in this experiment, if we talk about, see, we have probability to get a head is 1/2, but for no head is also 1/2, means no head means only get tail, right?
Yeah. Okay. Yeah. Right.
To get, either we can write here tail or no head
Okay.
is equal to also 1/2, right? So we can see in each case here or here, probability is less than 1, greater than 0 and less than 1.
1. Yeah.
Okay. So here we can conclude in each case Px, because we can take here or like x Px. X is equal to 0. For no head, we have 1/2. For x is equal to 1, and we have also 1/2. You got this distribution for this experiment? You got this?
Yes, ma'am.
Yeah.
Yeah.
So in each case, Px is equal to 1/2. So we can conclude that this is Px is greater than 0 and less than 1. Okay.
Okay.
For,
Okay. Yeah.
I'll tell you when we have 0 probability and when we have 1. Okay.
Okay.
And now let us see. And this is first property, okay? Probability is always greater than or equal to 0, but less than or equal to 1. So here Px
Okay.
is greater than 0 and less than 1. Now let us see the sum of probability. Summation Px is equal to, let us add these all values. So 1/2
Okay.
plus 1/2, we have 1. So second property you can see here, because sum of probability in an experiment, we have always 1. Always 1. You got now?
Okay. Yes.
Now let us see in this experiment. When a coin tossed twice, or we can say 2 coins tossed together, let's see now. So in each outcome, see, for each outcome, we have probability greater than 0, but less than 1. So here, Px, or we can conclude Px for any value of x, we have greater than 0, but less than 1. Because we have 1/4, obviously it's greater than 0, but less than
Yeah.
1. And also these values, right?
Okay. Yeah.
And now let us find sum of all these values. 1/4 plus 1/2 plus 1/4. So we have 1.
Okay.
So also second property verified. Got it?
Yeah.
Now let us see in third case when we toss 3 coins together or a coin toss thrice. So in each case, we can see each value is greater than 0, but less than 1. And now let us find
Yeah.
sum. Here for all values of x, we can write this line in previous experiment also. Here for all values of x, px is greater than 0 but less than 1. Now let us find sum, means summation px. Now let us add these all values. One by 8 plus 3 by 8 plus 3 by 8 and plus 1 by 8. So we have 1 plus 3 plus 3 plus 1. So 8 by 8, we have 1.
Yeah.
Okay.
Okay.
So now you got properties of probability.
Yes, sir.
So I'm checking the next topic in your syllabus. I think it's a binomial distribution. I think so. But let me check it again. Yes, we have distribution, geometric, binomial, multinomial, Poisson. Okay. So let us do this binomial distribution. Why? Because binomial distribution for discrete random variable. Okay. That is why.
Okay.
Because we'll do further topics accordingly. Okay. As we have done today, probability for discrete random variable or have done discrete probability distribution. That is why. See, here we can see when
Yeah.
we toss a coin twice, thrice, or like 4 times. But if we toss a coin 100 times, 500 times, 1000 times, then we can't find outcomes and can't find probability in this way. That is why we have binomial probability distribution for large number of trials. Okay. We use formula in a state by doing this way because we can find like 3-4 times or maximum like 5 times, because after 5 times you will have lots of outcomes. It will not be easy to write. Okay. That is why binomial distribution formula is drawn to find if we toss a coin 1000 times and we want to get hat 700 times, then how we can find it? We can find it by using binomial distribution. Okay. So let us see.
Okay.